Hello, grade 8. Today we will start to explain lesson 4.3 in your book, which is in page 107. In this lesson is graphing linear non-relation non-proportional relationships using the slope and y-intercept. Then we are going to represent linear non-proportional relationships using the slope intercept form to graph a line. Then we will start to recall that the line y equal mx plus b is the slope intercept form of the equation of a line. So once we have slope intercept form of the equation of a line, so we have to remember that y equal mx plus b. And we said before, what's m donated for? M donated for the slope. And what's b donated for? B donated for the y-intercept. So what about if you have the equation and you want to represent it graphically? To graph, first graph the point 0 and p, which is 0 and the y-intercept. Then use the slope m to find another point. Example, graph y equal 2 over 3x minus 1. As I said, first, where is the y-intercept? So we said we have to put 0 and then we will use b, which is negative 1. Then we will go to plot the points here, which is 0 and negative 1. Then 0 and negative 1, we will put the points. Second, use the slope, which is rise over run, 2 over 3 to get the second point. So we will start from this point. We count up 2 digits or 2 units and then to the right 2 units and then plot the second point. Then we will connect the 2 points with your line. Another example, y equal negative 5 over 2x plus 3. Where is the y-intercept? The y-intercept is 0 and 3. So we will put the point first. Second, negative 5 over 2. It's rise over run. Negative 5 means that you are going to move down 5 units and then to the right 2 units. If you want to break the rule and you want to count up, so we can say that you are going to count up 5 units and then to the left 2 units. Then it's your turn now to choose the way which you want to count. If you want to count 5 down, so it will be 2 units to the right. If you want to count up, so it will be 2 units to the left. Then you will find another order pair. It will be negative 2 and 8. Then you will connect between them. Here we have more examples. Note lines with a positive slope rise from left to right. So here in this one, it has a positive slope, so it's rise from left to right. But lines with negative slope falls from left to right. And remember that this one, it looks like the sign for correct, okay? And this one, it falls down like this falls from left to right. One more question. Y equal half x plus 1. Pick up the y-intercept, so it will be 0 and 1. And then we will use this slope, which is 1 over 2, means 1 unit up and 2 units to the right. And then you will connect between the 2 points. Another example, 0 and 4. So we will go stop on 0 and 4. And then negative 3 means negative 3 down and then 1 to the right. What about if you want to break the rule? It will be 3 up and then 1 to the left. Then we will continue to draw the line after you will plot the second point and then you will draw the line. In this case, as I said, so we have the general form, which is y equal mx plus b. You will start to use a y-intercept and then the slope to represent it graphically. Also, we can find word problems related to graph the non-linear relationship. Kate has a weekly goal of bringing 2,400 calories by taking bricks walks. The equation y equal negative 300x plus 2,400 represent the number of calories. Y Kate has left to burn after X hours of walking, which burn 300 calories per hour. So already we have the equation, which it was y equal negative 300x plus 2,400. So we have the initial value, which is 2,400 calories. And we have the rate of a change, which is the slope, is negative 300. And we want to represent this one graphically. First, we will represent by using the graph, okay? And we have to choose the scale. The scale down, he said here, represent the number of calories. Y, then Y represent the number of calories. Kate has left to burn after X hours, which means X donated for the number of hours. So the number of hours, it could be after 1 hour, 2 hours, 3 hours, 4 hours, and so on for the X axis. And here, this is the calories remaining. We put 600 and then 1,200 to be suitable to represent this one graphically. We will start from the y-intercept, which is should be 0 and 2,400, and we will put it up here. And then negative 300 means that you are going to move down negative 300 and then to the right 1 unit. Then we found the first point, and then now we want to find the second point. As I said, the slope, it will be, we will move down 300, then 2,400 minus 300, it will be negative 2,100. And then we will move to the right 1 units. If you want to find another order pair, it could be negative 600 over 2 or negative 900 over 3. Then you will stand on negative here, negative 900. This one, I'm sorry, this one, it will be 900 over 3. Then after how many hours of walking will Kate have 600 calories left to burn? After how many hours she has 600 burn, then you will stop in 600 and you will move to the right and then look down. So it will be after 6 hours. When will Kate reach her goal? She will reach her goal when? After how many hours? After 8 hours, she will reach her goal to burn 2,400 calories. Then, in this case, we can use representing non-proportional relationship in our real life. Because he said at the beginning, Kate has a weekly goal of burning 2,000 calories by taking brisk walks. This equation represents the number of calories Y Kate has left to burn after X hours. For this reason, we represented this one graphically. How? I said we can use the slope and the y-intercept. So we said the y-intercept here was 2400, and then the which is the initial value. The rate of a change or the slope was negative 300 over 1. So we can use another one. It would be negative 602 and then negative 903. So if I will go here, so this one is 2 and sorry, this one, it will be negative 900 over 3. All of these numbers, when you are going to simplify it, you will find back to the original one, which is negative 300 over 1. Then we can move down 900 over 3. So we will move down 900 and then over 3 hours to reach the next point. This is how we can use graphing in our real life. Another question: what if Kate decided to modify her plans, slowing her speed at which she walks? The new equation is y equal negative 200x plus 2400. Graph the new equation. Then we will start with the initial amount, which is the y-intercept, which it will be 0 and 2400. And then we want to use the slope, which it will be negative 200 down and then 1 to the right. And then you will connect the points together to reach your goal. Again, more 200 and then 1 to the right, more 200 and then 1 to the right till the end. Now we will connect the points together. In this case, you can note that how does the graph of the new equation compare to the graph of the last equation? Let me remind you the graph in the last equation. The last equation, you see the graph stopped where? She started from 2400 and she reached her goal after 8 hours. But in this graph, she's going to reach her goal after how many hours? She's going to reach her goals after 12 hours. Then to compare between the two graphs here, she started with 2400 in both two cases, but in the first one, she decreased 300 calories per 1 hour, but in this one, she decreased 200 calories per 1 hour. Then in the first case, she reached her goal after 8 hours. In the second case, she reached her goal after 12 hours. Then in this lesson, as I said, we studied how we can represent a non-proportional relationship graphically by using the slope and the y-intercept. And also we can compare between the two graphs. So the new graph has the same y-intercept, but the slope is negative 200 instead of negative 300.